Hey, good morning, everyone. How are y'all doing? You have a
Good
good
morning.
weekend?
Yes, sir. Super Bowl was fun.
How was that game? Did y'all like that game last night?
Yeah,
Did
it
you
was
watch
good.
it? No, Henry?
The team I wanted to win didn't, but it
I
was a
can't hear
decent
you.
game.
Hold on, let me check my audio real quick. It's probably on my end. Check, check, check. Okay.
Working now?
Yeah, now I can hear you. Yep.
I said the team I wanted to win didn't, but it was
Yeah.
a decent game.
Yeah, me too. I was hoping the Bengals would pull it off, but oh well. Okay, all right. Well, in terms of where we are here, we have our first test is actually a week from today. So it's finally coming around the corner. So today we're going to finish 3.4. There was some stuff we didn't have an opportunity to do. And then we're going to start 3.5. I don't know how far we'll go. And then next class, sorry, this is supposed to say Wednesday. We will do quadratic functions and their graphs. So the way that I plan on doing this is whatever we finish today, okay, will be the last bit of material for the test. All right. So whatever we do on Wednesday will not be on the test on Monday. All right. That way you have some time to absorb things. In terms of homework, I've pushed the deadline for 3.5 to, I guess, a week from today, instead of, it was supposed to be due on the 15th with the 3.4. So that doesn't mean wait till Sunday to do it. You can probably get it done by the end of the week, you know. But yeah, and then we have our test. So we will talk more about the test on Wednesday. I plan to give you some sort of review, and that will help you, I guess, prepare. And then we'll also talk about how we're going to do it on Zoom and all the logistics and everything else. So I would encourage you to look at the syllabus. The syllabus explains how I run the test on Zoom. So maybe read through that before we meet, and then I can clarify things and kind of show you how it's going to be done. All right, any questions? All right, last time when we finished up, we were talking about the floor function and ceiling function, these step functions, greatest integer function. That's kind of where we ended. And we still need to talk about piecewise functions. So that's where we're going to start today. So this idea of a piecewise function is actually very important in calculus. I feel like I'm a scratch record. I keep on saying how important things are in calculus over and over, but they are, okay? So the idea of a piecewise function. First, we need to understand what is a piecewise defined function. So what I'm going to do here is I'm bring up my graphing utility here. Give me just a second. What I'm going to do is I'm going to graph two functions for you, okay? The first function is going to be y equals negative 2x. Equals. And the other one is y equals the square root of x. All right, there we go. So these are two functions that we should be somewhat familiar with. Like these, that's a line, negative 2x is a line. And then y equals the square root of x. We talked about that last class when we were talking about these functions, this library of functions, right? So they're the two functions graphed together. What a piecewise function is a new function that is made up of multiple functions. So right now I have two functions, but I'm going to define a new function. And this new function, unfortunately, I have to clear this out. This is the definition of the new function right here in yellow. Well, let me not do the yellow. Let me just circle it. So in red here, that is the new function f of x. And the way it's defined is, well, it's two different functions. First, it's negative 2x, but it's only negative 2x if the x we're plugging in is less than 0. And then it will be the square root function if the x we're plugging in is bigger than or equal to 0. So that means 0 is where something is happening, right? If we look at the graph at x equals 0, we should have something interesting going on. To the left of 0, that's what this means, left of 0, right? To the left of 0, it's going to look like the line. And then to the right of 0, we want it to look like the square root function. So what I'm doing is go back to that graph I showed you. Right now, do you all agree that right now, if I graph these two together just like this, this is not a function? Together, it's not a function because it would fail the vertical line test, right? If I draw a vertical line, I'll hit twice. So this is not even a function. But if I do some sort of restriction and only draw the red one to the left of 0, so what I'm going to do is add a restriction up here. I'm going to say x less than 0, and see now it actually will just draw that line to the left. And then this one, I'm going to put x greater than or equal to 0, and that'll draw it to the right. So now these two together is the piecewise function f of x, all right? So two functions kind of pasted together where they will transition from one to the other at some point. That is a piecewise function. And so what we want to be able to do is answer some questions about this function. So let's start with the first question. So part A, we want to find f of -4, f of 0, and f of 4. All right, so it's Monday morning. Let me call on somebody. How about Araceli? You here?
Yes.
How's it going?
Hi.
Doing all right?
A little bit under the weather, but overall good.
Okay. So my question to you is, looking at this function, if I ask you to plug -4 in, what are you going to do?
Would it be 2 parentheses -4?
Yes. Good. So we're going to go, I don't know, did you say -2 parentheses -4? I think that's what you said.
Yes.
Okay. So Araceli, why are you plugging it into this one and not this one? Why'd you plug it into to the top function, not the bottom one?
Because it's greater than 0? Is it?
Okay. What number are we plugging in? -4, right?
Oh yeah, -4.
That number is less than 0, right? -4 is less than 0. So that's why we plug it into the top function. It would not be okay to plug it into the bottom one because, -4 is definitely not bigger than 0. So we don't plug it in there. So the value of x we're plugging in dictates which piece of the function we're going to use. Good, good. All right, now that would just be -8, right? Or sorry, +8. Okay, next up, thank you, Araceli. Next up is Gloria. Gloria, you here? Gloria? No Gloria? I don't see Gloria. All right, how about Lizeth?
I'm sorry, my camera wasn't on.
No, it's okay. F of
Let's see,
0.
0, it would be with the radical.
Okay, so the top or the bottom function?
The bottom function,
Bottom. And the reason?
because it's equal to 0.
Yeah, because 0 is what we're plugging in, and 0 is equal to 0, right? So we want to plug into the bottom one. If you try and plug 0 in here, right, 0 is not less than 0. They're the same. So, okay, we're going to plug it into the bottom. Square root of 0, and the square root of 0 is?
0.
0. Okay, all right. And then last we plug in 4. Let me get someone else going here. Jose?
Hello, good morning.
Good morning.
It will be, let's see, 0 as well.
So where are you plugging in? You're plugging in 4, right?
4, yeah.
So are you going to plug it into the top one or the bottom one? and why?
The bottom one, because it will be greater or equal to.
That's right, because if you plug in 4 is greater than or equal to 0, so you plug it in there.
Yes, sir.
All right, good. So we'll go square root of 4, and then that would be 2. You know, I've always thought with piecewise functions, I've always thought it would be easier for students to understand if we wrote it this way. If we just wrote like, if x is less than 0, then do negative 2x, and then if x is greater than or equal to 0, then do square root of x. I think that like reads better, right? It's like first you check where your x is, and then you go plug it in the function. The way that we write it, the notation is we put the function first, and then we're telling you like what the condition is. Does that make sense? We put the condition at the end. We live with it, right? Okay, so next question, finding the domain of the function. So when we talk about domain, we're talking about, are there any values that we cannot plug into this function? So let's think about that. When you think about this function, any x value less than 0, we plug into negative 2x. Are there any domain issues with negative 2x? What do y'all think? Is there any number you cannot plug into negative 2x? No, right? Because you don't have division by 0, you don't have a square root. So there's no domain restrictions for negative 2x. And we're going to plug in values less than 0. So like negative numbers in here, we plug them in, we should have no problem. So far, no issues. If we think about like a number line, you know, here's 0. We know right now that if you take any number to the left, right, we're good. But now what we need to consider is the other part of the domain, which is where x is 0 or bigger. And the question is, are we still allowed to plug any of these into the function? What do y'all think? Yes or no? I see Zane saying yes. Yes, right? Because if we plug in these numbers 0 and anything positive, now we're going to be in the bottom function. And the square root function is valid for 0 and positive. It's just not valid for negatives. But it's okay because anytime we plug in a negative, we're in a different function. So we should have a domain of everything, negative infinity to infinity. All right, how about X intercepts? How do we find the X intercepts of, sorry, let's start with X intercepts. How do you find the X intercepts of any function? Well, you take the function and you set it equal to 0, right? You don't plug 0 in, you set it equal to 0 to find the X intercepts. So the way you have to do this is you have to figure out what X value gives you 0. You want to set both of the pieces to 0, both of them. You have to look at each one separately. So I set negative 2x equal to 0, and I set square root of x equal to 0. The first equation is easy. I just divide both sides by negative 2. I get x is 0. And then the other one, I plug in, I'm sorry, I can just square both sides. I get x is equal to 0, and that's the other solution. So tricky question here. I'm looking for X intercepts. I set each of the functions equal to 0, and I get 2 solutions. They happen to be the same answers here, right? Am I going to look at both answers right now and say, you know, like, do I really want to consider this one? Let me just put it this way. Do I want to consider that answer, yes or no? Think about the domain of this function up here. The negative 2x is only when what? When x is to the left of 0, right? And we're saying that that function will be equal to 0 when x is 0, right? But we're not allowed to be looking there, right? X can't be 0 though. It strictly says x has to be less than 0. So even though we got an answer of 0, I'm not going to consider that as an answer at all because it's outside of that piece of the function. Not allowed to look there. Now on the other one, I get 0 as an answer. And when I come up here and I check, well, yeah, when I'm on the square root function, I'm allowed to have x as 0. So this will be our answer. Now, I understand they are the same answers. But let's just say for the sake of argument here, let's say that this answer was X equals, let's say 2. Let's just say it was 2. We would not want it, right? We would throw that answer away because this value 2 is not less than 0. Okay, we would throw it out. What if it was -2? Would we take it or throw it away? What do you think? If this answer happened to come out to
We'd
be
take
negative,
it.
we keep it, right, Henry? Because if it's -2, right, -2 is less than 0. So when you're finding X-intercepts, you have to look at each piece, and then whatever answers you get, you got to make sure they fit within that window that you're given. Questions? It's a little weird. What about Y-intercept? Go ahead.
I'm sorry, I was just gonna ask if we're gonna do another one similar to that one, because when I was trying to do the homework, I think, yeah, it was the range. Trying to find the range was just messing me up the whole time.
Yeah, let me see. Yeah, we'll do the range in a minute.
Okay, thank
Okay.
you.
Yep. So Y-intercept, well, to find the Y-intercepts of a function, it's different than finding the X-intercepts. For the Y-intercepts, all we do is plug 0 into the function. That's all you do to find the Y-intercept. And we've already done this, haven't we? On part A, the second one was f of 0, and we already know the answer is 0. So we have a Y-intercept of 0. All right, the next thing to do is graph. All right. Now, I already graphed it using a computer, but let's act like we didn't have a computer. All right, let's just see how we would graph this. I'm actually going to erase this and copy this and take it to a new page, show you how I graph this. Okay, so I recommend using pencil here if you're going to graph this. Okay, so here's the way I would do it. First, I'd start out with my X and Y axes like this. It's terrible. Okay, and let's start with the -2x. So -2x, you need to know that -2x is a line. You need to know that. In fact, you need to kind of look at it as y equals mx plus b. And if we write it that way, the slope of the line is -2, and the y-intercept is 0. So look, everyone's got a kind of different background in terms of your comfort graphing lines, but I'm trusting everyone here does know how to graph a line. So if you don't, we need to talk. So the way I'm going to do this is I'm going to start by looking at the y-intercept, which is 0. I'm going to put a dot there at 0 on the y-axis. And then I'm going to draw a line that has a slope of -2. And I'm going to rewrite -2 as -2/1. And that means I go down 2 and to the right 1 to get to another point on my graph. So I'm going to go down 1, 2, and to the right 1. And I'm going to put a dot. Okay, I'm writing in pencil right now. Okay, I'm doing this in pencil. I'm going to do this very lightly. I have a line that goes through here like this, like that, right? There's my line. But because of the domain restriction, I'm only supposed to draw this line to the left of 0, right? So I'm going to come in here and erase this part over here and only have this part on the left side. So I have to erase it. Okay, and put this line, it's going to go like this. And it just keeps on going up forever and ever. Now at 0, right here, at this point, right there, do I have a solid dot or do I have an open hole for this graph -2x? What do you think? Javier, are you here?
Yes, sir. It's gonna
What do
be
you
open.
think? I'm sorry?
Open.
Open, right? Because of it, the inequality was x less than 0. So the line only exists to the left of 0, doesn't exist at 0. So we will put an open hole here. Very good.
Yes, sir.
I'm going to put that open hole like that. And that. There we go. So we have graphed the left side. Now, what I do next is I go and I look at the other function, square root of x. And now I'm like, oh, that's the library of functions. I know what that one looks like because we learned that last class. And I know that the square root function looks like this. Oh, geez, that was terrible. There we go, something like that. Okay, I have to know that. And I want this graph whenever x is bigger than or equal to 0. So that means at 0, I do want a dot. So it fills in that hole from the line, it fills that hole in. And that's our solid, our complete graph. Any questions? Okay, Alyssa, are you here?
Yes, sir.
Okay, Alyssa. So we're going to talk about the range of this. I think Sierra had a question on this. The range, I think, was the next thing they wanted. So we were supposed to graph it, which we did. And it says, use the graph to find the range. So what do you think? When you look at this graph, Alyssa, can you tell me what the range is?
Would it be anything greater than 0?
Okay, good. Now, so when we talk about range, we're talking about what y values come out of the function, right? So we have, up here we've got y values, right? If you look left and right, you see graph. Anything below the x-axis, we don't have graph, right? So you said everything bigger than 0. I agree. And because of the arrow on this line, it keeps going forever. The question is, do I include 0 or not? So do you actually ever get 0 to come out of this function?
Yes, for
Yes.
the square root.
Yeah, you do, right? So your range will be everything from 0 to infinity, including 0. So the way we would write that for this is bracket 0, comma, infinity. Sierra, does that address kind of a little bit of your?
A little bit more. I think I'm
Okay.
just gonna have to like practice it some more to like get it down pat, but yeah.
Okay. Just remember range, you're looking up and down, or you're looking on the y-axis, you're looking kind of left and right, seeing where you have graph. Okay, we good? Understand? Kind of? Let's look at the next one. I have another example. Okay, now this is a different piecewise function. Notice that for this piecewise function, there are 3 pieces instead of 2. And there's really no limit to how many pieces you can have in a piecewise function. All right, you can have, 100 pieces to a piecewise function. So there's a piecewise function. All right. So I want to look at what's happening here. It looks like if I look at the restrictions, I first am supposed to be between -3 and 3. I'm going to try and graph this first before I do anything else. Let me get my graph paper up here. Go smaller here. Okay, so let me try this. I'm going to look between -3 and 1. Okay, so here's -3. 1, 2, 3. Let's say that's -3. And here's 1. And when I'm between, it's almost like there's this window in here, right? There's like it's like a region right in here. In this region, I'm supposed to be this -2x plus 1, which -2x plus 1, Zane, that's a what? But when I go to graph this, this is a what?
A line.
A line, right? Can you help me graph that, Zane? If I were to ask you to graph that, how would you graph that?
I'd go on the y-axis and I go up 1, and then I do a line going down 2 and then over 1.
Let me do that. I'm going to go up 1 on the y-axis. There's 1. Okay. And you want me from there, you're just picking off the y-intercept, and then from there, you want me to do what?
Go down 2 and over 1.
Yeah, use this slope. So this is going to be -2 over 1. So down 2 to the right 1. So I'm going to go down 2 over 1. I'm going to put a dot there. Okay. And then you want me to draw a straight line?
Yes.
Yes. Okay. So I'm going to draw this straight line through here the best I can. And I'm going to stop right, Zane? I'm going to stop when I get to -3, and on the right, I'm gonna stop when I get to 1 on the x-axis, right, Zane?
Yes.
Okay, good. One more thing, Zane, you're doing good with this. On the left side of this line, this is like a line segment, right? That's what we have here, a line segment.
Mhm.
On the left side, Zane, do I have a dot at the end of this or do I not?
You do,
I do. Why?
because it's equal.
Yep,
Negative
because
phase.
this equal sign here. So I'm going to put a solid dot here. And then what about when I get to 1 down here, Zane? Am I going to have a dot or an open hole?
It's open.
It's open, right? And that's because I do not have the equals there. So I'm going to put an open hole here. Everyone understand that? Between -3 and 1, we've got this little line segment. The left end point of it is solid. The right end point of it is open. Good job. All right, Zane, I got Zane. Where's Zane? Good. How about Ashley? Where's Ashley? Ashley here? Ashley.
I'm here.
Oh, there you are. All right, Ashley, you following?
Yes.
Okay, so what about this next piece, this middle piece? 2 if x is 1. What does that mean? What do you think it means?
Don't you have to move over to?
So this right here, this x equals 1 is telling you, hey, look, right? It's saying, Ashley, look, when x is 1, I want the function to be 2. That means it just wants to spit out the value 2, right?
Okay.
Right.
Mhm.
So I'm going to go to the right one on the x-axis, and then the value needs to be 2. So I just need to go up 2 slots, right?
Okay.
And just put a solid dot there. And that's it. That's all it is. Does that make sense, Ashley?
Yeah.
If x equals 1, just go up to 2, put a dot.
Okay.
Okay.
Mhm.
All right. Now let's move on here. Diego, you there?
Yes, sir.
Okay. So the last piece here, Diego, is the x squared function, and you only want to draw it if x is bigger than 1. So how would you do that?
So you, the way that I started it, whenever I drew it, is I sort of like drew dashed lines
Mhm.
up until the like 1
Mhm.
or up until x is equal to 1, and then
Yeah.
I start drawing a solid after I reach x is equal to 1.
Yeah.
So
So
I just draw x squared starting from 0.
so maybe you just draw it first, right? Like x squared, draw the function first.
Yeah.
I don't know if that's what you mean. And then use the restriction and just draw it like to the right of 1.
Yeah.
Am I
So I just
understanding?
erase
correct?
everything else.
Yeah. Now you do have to know a little bit about this function, right? Like, see, something interesting is happening at 1, right? We're only drawing it to the right of 1. So it'd be nice to know what the value of the function would be at 1, right? If we plugged 1 in here, we should get 1 squared, which is 1. So we know that the graph starts here at 1. Watch what I'm gonna do here. I'm gonna do it in a different color. What color? Black. Okay. So right here, it starts here and then it goes like this, right? And the rest of the parabola graph thing, I can just get rid of. I just can use it first to get a basic idea, but then only draw it to the right of 1. Diego, why did I put an open hole here, Diego?
Because it's everything to the right of 1. So it
To the
would
right
be
of 1.
open.
Yeah, not including 1. All right. Kind of makes sense, y'all? Piecewise functions. We need to finish this problem. There's a bunch of questions for it. So let me get to the questions here. I'm going to go back to this. And let me go back to my picture. I'm going to put the questions in right here. There we go. Okay, so why don't you take 5 minutes? Not even 5, maybe 3 minutes. I think the only things that we really need to answer here are this one this one, and this one. Yeah, maybe like 4 or 5 minutes. See if you can, using everything we've done here, see if you can answer those questions. All right. And then I'll call on some people here in a minute. I think it's obvious that the domain and range are probably the hardest here, but we'll see. We'll talk about it. Just let me know in the poll if you're finished, do yes. If you're not finished, just ignore the poll for now. I just want to see when people are done. Just go another minute. Just about half of you say you're done. So let's go through this. Malak, are you here?
I'm here.
Hey, so how about, okay, assuming nobody has questions with A, are there any questions on part A? Plugging the values into the function? Everyone understand why we're plugging in, you know, which piece we're plugging into when we plug in those numbers? No questions there? We're good, okay. So Malak, how about part B, doing the domain? What do you think? Do you understand it, or do you want me to help you with it?
I don't understand.
Okay, so when we talk about domain, what we're saying is, where does the graph exist in terms of the X values? So let me just ask you this right now, Malak, if I come over here way to the left, over here, -7, and plug in, do you see any graph up here or down here? Do you see any graph at all?
No.
No, okay, so where does it start? Where do you start seeing graph, up or, you know, above or below? At what point do you start seeing it?
Wouldn't it be at the one?
One,
Oh, -3, I'm sorry.
-3, good. So at -3, that's the first place, and we actually have graph up there, right? So we're gonna say, starting at -3, right? Okay. And now keep looking, Malak. When we keep moving to the right, we keep hitting it, right? We're gonna have graph, we're gonna have graph, graph. We have graph. Now at 1, we have something interesting. At 1, do we hit graph at 1, Malak?
No.
So if I go to 1, which is right there, and I look up and down, will I hit something? Well,
Oh,
when I
yes,
hit
you
that
will.
point, I do, right?
Yeah.
I do have a point there. So I do have graph at 1 still. And now if I keep going to the right, I'm gonna hit that parabola, right? And that thing keeps going forever. This arrow keeps going up and it keeps moving to the right, slowly to the right. So do you agree that I'm gonna just keep on hitting forever?
Yes.
Okay, so I'll put infinity here. Make sense?
Yeah, I get it
Okay.
now.
Got it? Anybody else have questions on that? Thank you, Malak. Sierra, yeah, Sierra, perfect, because you were having the issues with, let's do range, Sierra, because now I kind of scribbled all over this damn thing. So let me erase some of this, so maybe it won't be so confusing. Ah, shoot. Okay. Okay, in terms of range, Sierra, tell me about the lowest value you ever see. What does it look like?
The lowest value, wouldn't it just be infinity? It
So
could be
does the graph keep,
infinity?
does the graph keep, when you look, start from the bottom. How about this? How about -5? Look to the right and to the left and tell me if you ever hit graph. Do you hit anything?
No.
No, okay, and then keep doing that and tell me when you start to have something happen.
Okay. Yeah, right there.
Right there. So what is this value? What does it look like?
-1.
-1. Now, big question here. Do you actually have -1 or not? Look at what's happening there. What is this here? Is that solid or a hole?
It's open.
It's open, which means you actually don't ever get -1, do you?
Oh, so it's not included.
It's not included. We'll still
Okay.
put -1, but it'll be not be included. With me?
Yeah, so it'll be parentheses instead of a bracket.
That's right. Good. Now keep moving up and tell me, you know, we're hitting. I think we keep hitting, don't we? I mean,
At
like,
1?
we're always hitting something,
Yeah.
always. Now, when we get up here, the one on the left stops, right? Correct? But we still have the graph on the right that we're hitting,
Right.
and that goes forever. So I'll just put comma,
Infinity, right?
infinity. That's it. Yeah. Does that make a little more sense?
Yeah, that made way more sense that way.
So when you're looking domain, imagine like Malak was doing, when we do domain, we're looking up and down, seeing when we hit. And when you're
Mhm.
doing range, you're looking like left and right.
Yeah,
Coming from
see,
the
I got
bottom.
the domain, no problem. I don't know why I was having problem with the range, but yeah, that cleared it up a little bit more.
Okay.
Thank you,
And now
sir.
the intercepts, you can tell from the graph that we have a y-intercept of 1 and an x-intercept. To get the x-intercept, all you have to do is take the top, this red function, the red one, because that's this line, and you can see it hits the x-axis right there. Right, that's our x-intercept. So you take this one and set it equal to 0. This is for the x-intercept. And when you solve that, you'll get a half. Okay, we need to move on. Any questions over this? Piecewise functions. Would you all like me to talk about a real world piecewise function? A function that you would actually see in the real world? Do you think that would be beneficial to you?
Yes.
Okay, let me do this. I'm going to give me a moment here. Let me do this off screen. It's going to take me just a minute to bring this up. I'm actually going to bring up my CPS bill. Maybe. Let me see. I've got to log in real quick. I want you to be able to see it. So energy is getting very expensive. Well, everything's getting expensive, but come on now. All right, view my bill. All right, here we go. So I'm sharing with you my CPS bill. And I'm going to move to this page right here. So I'm going to copy, let's just look at the electric bill. Okay, here's my electric bill. So I'm just going to copy that. You know what? Hold on. Yeah, that'll work. All right, so this is just for my electricity. All right. And don't worry. Well, let's just go through these one at a time. So the first thing on this bill is a service availability charge. That's basically every month I get charged a certain amount, okay? No matter whether or not I use the electricity or not, right? If I go out of town and turn off all the power in the house, I'm still gonna get charged $8.75 per month, right? So that's fixed, right? This is a fixed cost. Now, the next thing I get charged is, let me see, hold on a second. Give me a second here. This bill looks, this bill's not showing it. You know what? I might have to do something different. This bill doesn't break it down the way I want it to. Hold on, let me do this. Sorry, y'all. Don't want to see it, so I think it's worth seeing. Come on. Should have done this one first. There we go. All right, how about this? We'll do my water bill instead. I know for sure this one. Yeah, okay, domestic one. Yeah, I might have to find, I have to find a month that I have to find a month that I used a lot of water. So hold on, let me go back to August. There we go. Okay, we'll try this. Okay, so the way it works now, this is hard to read. Okay, but I'm going to try and break this down. This right here, the 1667 is a fixed cost. Same thing as the electricity. No matter what, if I don't use any water, I've got to pay $16 a month, no matter what. Okay, and then I get charged per certain amount per gallon. All right, and the first line here is telling me that I'm going to get charged 0.0962. That's basically 9 cents per 100 gallons, 100 G. And how many gallons did I get charged that on? 29.92. And then below 29.92, I get charged another 31 cents per 100 gallons. So basically, I have to do this quickly. Basically, what we have is a function here. I'll call it C for cost. And the way it works is I'm going to get charged a certain amount. Let's just go with this number. It'll be like 0.0962 if X is less than 2,992. So if I use less than 2,992 gallons, I'm going to pay this much per 100 gallons. Okay. But if I go over that, okay, if I go over that, then what I'm going to get charged is not only the 0.992 or 0.0962. Not only am I going to get charged that for the 29.92, I'm going to get charged all of this crap right in here. This right here, this 14.97 is how much I went over the 29.92. So if I go over, I'm going to have a different number here that I use, a different function that I'm going to use in order to determine the cost of the bill. Now, I know this is not like me getting into the fine details and actually creating the piecewise function, but this just shows you how, like with both electricity and with water, if you use a little bit of water, then you just pay a certain amount. But if you go over a certain amount, you go into a second tier where now you're paying more for the water. And then if you go over, there's like I think 3 or 4 tiers. If you get into the third tier, then you pay even more, right? So those are piecewise functions. And that's why it's hard to read a bill sometimes when you use a lot of water or a lot of electricity, because those tiers come from a piecewise function, which they don't give the piecewise function to you. So you mathematically have to create it yourself to understand it. So it's a little bit tricky. Anyway, okay, I don't want to go into this more. Just know that electricity works that way, water works that way. Phones used to work that way. I guess they still do. What happens if you go over, if your cell phone plan has a certain number of minutes or gig that you can use? Like if you go over, right, then you have to start paying more. Those are piecewise functions, right? It's a certain amount till a certain point, and then it changes. So anytime you have a function that behaves that way, it's piecewise. Okay, let me see here. I'm ready to move on. So we did that. Okay, we're going to 3.5. Graphing techniques. So at this point, we have the library of functions that everyone should know, right? Those are what we talked about last class. You know, all the root functions and the absolute value functions and all these things, you should have a mental picture of what they look like. Okay, I mean that, like, I now expect that everyone here recognizes all these functions we talked about last class, cube root, square root, all that stuff. So now what we want to do is we want to see how you can use that knowledge to graph things that are a little more complicated than those basic functions. So we want to take our knowledge of the basic functions to graph more complicated ones. And this right here is a summary of all of the different what we call transformations that we can have for those functions we learned last time. So the first transformation here that we need to be aware of are what are called vertical shifts. So if we take any of the functions that we learned last class and we add a number to them or subtract a number, all this will do is either shift the graph up or down. That's all it does. Okay, so let's just do a quick example. Let's say I want us to sketch f of x equals the square root of x plus 3. All right, what I need to notice here is first, I recognize the square root of x. I know what that looks like, right? So in my mind, I already know that it looks like this. Okay, I know that, that's square root of x. And then adding 3, I need to now understand with these transformations that all it does is moves the whole graph up 3. So remember this point here that was at the origin, right? That's at point 0, 0. That it now goes up 3. 1, 2, 3. Here's 3. And then it goes like that. That is the graph of square root of x plus 3. Now, I could now easily ask you for this function, what's the domain, right? The domain would be from 0 to infinity, right? From the left point is 0, it goes out forever. The range is from 3 to infinity, including 3, right? It's because you can just see visually that it starts at 3 and we get every y value going up. So that's a vertical shift, what we call a vertical shift. Let me get to the next one. So that's our vertical shift. We're adding a number or subtracting a number on the outside of the function. Now a horizontal shift is a left or right shift. And this is always tricky for students, all right? Because of what this says here. It says, if we take our function, we add a number inside the function, in the function. Notice the k here is outside that x, right? The x is in parentheses here. The k is on the outside. Here, the h we're adding is inside the parentheses with the x. Anytime we add a number, it's going to shift our graph to the left by that much. It's opposite of what you would think. You think adding a number would make you go to the right, but it's the opposite. Adding a number inside the function makes you go left. And if you subtract a number, it makes you go right. So let me show you an example of those. So let's just stick with this. What if we were asked to sketch f of x equals the square root of x plus 3. And let's do that versus another graph, g of x equals the square root of x minus 3. So again, we look at both of these, we say, square root function, right? So for both of these, I know that the basic function looks like this, right? That's square root of x. This first one, Annika, are you there? Annika. Okay, Dominic? Caitlin.
Here.
Okay, so Caitlin, You see on this first one on the left, we're adding the 3, right? We're adding 3. But do you understand that that 3 is inside the function as opposed to the example above it where the adding the 3 is outside the function? Does that make sense to you?
Yeah.
Okay. So if we add a number inside a function, that's going to be a horizontal shift. Which way though?
To the right.
That's what you would think, right?
Oh,
Because plus
to the
3,
left.
it's going to go left. All right. So anytime it's inside the function, it goes opposite of what you'd think. So what I'm going to do is I'm going to grab that point. I'm going to move 1, 2, 3, put my point here, and then draw my square root function. Look, these are quick sketches. It doesn't have to be perfect. All right. The whole idea here is that we can sketch something fast. Now on the next one, Zachary, what are we going to do?
It's we're gonna shift it to the right.
To the right. Okay, because it's a -3 inside. So we take that point 1, 2, 3 right there, shift it right. Good. Any questions? How about this? Do another one. How about f of x equals the absolute value of x plus 4 minus 4? I'll take a volunteer for this one.
You would, oh,
Go ahead, Henry.
you would go left 4 and then down 4.
Yes, we're going to go left 4 and down 4. What are we going to be doing left 4 and down 4 though? What am I drawing?
Oh,
So
isn't
what is
that
this?
a,
What does this library function look like?
is that a horizontal line?
The absolute value. Do you remember what the
Oh.
absolute value function looks like?
Um,
So we need to know what the absolute value of x looks like if we're going to be able to do this problem, right? Henry's
Is it like
saying
the
yes. We
V
should
one?
left. Say again.
is it like the V one?
Yeah, it's the V, exactly. So we need to know that this is the absolute value of x, right? We need to kind of know that. And now, like Henry said, we're going to go left. This plus 4 means left 4, and this means down 4. So I'm just going to take this picture. I'm going to go left 4, 1, 2, 3, 1, 2, 3, 4 to -4 here. And then I'm going to go down 4, 1, 2, 3, 4 to -4 here. And that's where that base point of that V is going to go. It's going to go left 4, down 4. I put it right here. And then I draw another V. Okay, now I'm going to put someone on the spot here. Thank you, Henry. Let's see, Michael, you there? Michael?
Yeah.
Okay, Michael. So my question is, looking at this graph right now, this graph, can you tell me quickly the domain and the range? What's the domain of this function f?
The domain be -infinity to infinity.
Yep, because if you look left and right, you always have graph. Very good. What about range? So now you're looking left and right. Where do you start seeing graph? And then where does it go to?
Be -4
-4
to infinity.
infinity. Now, do I include the -4? Do we have a solid dot there, or is it an open hole?
Oh, it's a solid dot, so it'd be bracket.
Yeah, bracket. Okay. Now look, I mean, there's a lot of things I could ask with this now, right? I could ask domain, range. Do you remember when we talked about functions increasing and decreasing? Remember that? I could ask you where this function's increasing and decreasing. So like everything we've done already now is in play. We just don't have time to go through every little nuanced detail of this. The main idea is if you know the basic function, move it around, and then all the questions that we asked before are kind of on the table now. All right, so that is your vertical and horizontal shifts. Okay. The next thing we can do is this thing called compressing or stretching. All right, so what does this first one say? First one says, if we put a number A in front of the function, multiply, and that A is a positive number, right? Then what it's going to do is somehow either stretch it or compress it vertically. Okay, so you will, this is tricky, you will stretch the graph vertically if the number you multiply is bigger than 1, and you will compress the graph vertically if the number is between 0 and 1. So let me show you an example. All right, I'll show you just a basic example of this. So I want us to look at a couple of graphs. Let's look at f of x is, let's go back to the absolute value of x. Let's make g of x 4 times the absolute value of x, and let's let h of x be equal to 1/4 absolute value of x. Okay, if I were to ask you to graph all three, sketch all three of these should be quick sketches. The first one we know is just a V, right? Like this. So, Sana, are you there? I know you were having some computer problems. Are you there?
Yeah, I'm here. Yeah, I don't
So,
know why I
Sana,
was lagging earlier.
you're okay though?
Mhm.
Okay, so Sana, on this middle one, putting a number 4 in front of the absolute value of x has the effect of doing what? Let me
Is
go back to
it-
this. So we're putting a number like this a, right? We're putting a number in front of the function. We're putting 4,
Mhm.
right? And look at this blue and green. This will tell you which one it is.
It stretches the graph vertically.
Stretches it vertically because we're putting a number bigger than 1 in front.
Mhm.
So a vertical stretch looks like this. If you look at the graph on the left, this is like the original square root function. To stretch it vertically means you're taking all points and raising them up, stretching them though. This base point at 0 does not move. Everything else gets stretched up. So it becomes like a tighter V, okay?
Mhm.
And then we'll stick with you, Sana. What about on this one? If this is square root of x, what does putting a 1/4 in front do? So now you have a fraction, right, in front?
Mhm.
It's going
Was
to,
it compressed?
it compresses. So what that looks like is it's like it flattens it out further,
Mhm.
okay? So it's either like making it more like narrow or it's flattening it out. Good. Miguel, are you there? Have I called you Miguel? I don't think I have. No.
No, you haven't.
You following?
Yeah.
Okay, so Miguel, I'm gonna like throw a good one at you here. How about this? F of x equals 10 parentheses x minus 3 squared plus 2. Okay, so don't freak out. Let's go slow here. First thing, Miguel, can you tell what the basic function looks like here? If you go back from last class, do you recognize like our basic library function? Let me see. If we go back, here's our library. We have the square root function. It's not a square root, right? Because we don't have square root there. Let's see. We had the cube root function. It's not that. Absolute value function, not that. How about this? The square function, x squared, right?
Yeah.
So we know what x squared looks like, right? Well, you do, yes.
That's quadratic, right?
Yeah, it's quadratic. So it just looks like a little parabola, right? A little U.
Yeah.
Okay, so we know that now. We know that this is going to look like a U, right? This is going to, the basic function here is this. It looks like a U. Okay, so now, very important, everyone. When you do these transformations, there is an order that you have to do them in, all right? And the order is, it's like an order of operations. You're always going to start next to the X. So it's like if I asked you to plug in X right now, right? If I asked you to plug in X, the first thing you do is subtract 3, right? So Miguel, a subtraction of 3 inside the function does what?
Move it right.
Right 3, okay? So the first thing we're going to do is we're going to move this whole graph right 3. Good. Now, the next thing I'm going to do after I do that is take that and square it, right? That will create the parabola. Okay, that's what creates the shape. But then I would multiply by 10. So Miguel, multiplying by 10 out in front does what?
Does it stretch it?
It's stretch, right? That's a vertical stretch. And then one more thing. What?
And then it'll move it up 2 times.
And then the
Or 2
last thing,
spots.
move it up 2.
Yeah.
Okay, up 2. So the first thing we did was that, right? The second thing was this, and the third thing was this. You can't do it. You cannot just do it in any order that you want to. It has to follow the order that I just went. It's like an order of operations. You start on the inside with the X and work your way out. Okay, so let's do these. I'm gonna do a little bit better graph here. If I started with just a basic parabola, okay, first step would be move it to the right 3. So I go 1, 2, 3 here, and now my parabola looks like this. Okay, so that's me doing the first step. Understand? Just move it right 3. Next, a vertical stretch by a factor of 10, which is going to just take this graph and make it really, let me do a different color. It's going to make it really narrow, like this. Now it's a parabola. It's a parabola, so don't make it look like a V. It's still got to have a curve down there. So that's me doing the second transformation. And then the last thing is to move the whole thing up 2. So I'm just going to take that parabola and just move it, shift it up 2. So I go up 1, 2, I put a dot here and then put my real narrow thing in there. Oh yeah, that's my third thing. So the green is my answer, okay? The green is my answer. You don't have to draw all the other graphs. It's just, this is to help you see it moved right. It got stretched vertically, which made it narrow, and then the whole thing went up 3. Questions? All right, there's more transformations. Good job, Miguel. All right, that's the stretching. Now, if we multiply by a number inside the function, okay, that does something different. It's going to stretch the graph horizontally if the A is less than 0, and it's going to compress it horizontally if the number is bigger than 1. So if the number is between 0 and 1, then it's going to stretch it horizontally. And if it's bigger than 1, it's going to compress it. This is actually really important in pre-cal, the next class after this. So let me show you an example of this. Let's say we take, I want to show you 3 different functions. So let's say we take the function, what would be a good one? Let's do absolute value of X. And now I want to do 4 absolute value of X, or absolute value of 4X. And then here I want to do 1/4 inside the absolute value. Notice where the number is, right? Notice the number is inside the absolute value instead of outside. Here's what we get. This is a V. It's our normal V. Can y'all tell me what this does? If the 4 is inside, let's see. What did it say? Where the heck is my notes? Okay, so if you put a number inside, right, like 4, and that number is bigger than 1, it's going to compress it horizontally. That means it's going to push it in, right? Push it in like this. When you push it in, what effect does that have? Imagine taking this graph here and taking that side and pushing them in. Isn't that going to make it look like this? It's almost like a vertical stretch, isn't it? It's almost like I stretched it vertically. Instead, I compressed it horizontally, which is really kind of the same thing. And then if I have a 1/4 inside, well, what does it say if you have a 1/4? Well, if the number is between 0 and 1, it's going to stretch it horizontally. It's going to pull it apart. So now it should look like this. Questions? We have a few more to do here with these transformations. Okay, last two, reflections. So the first one, reflection about the x-axis. If you ever put a negative number in front of the function, it's going to flip it over the x-axis. If you ever put a negative number inside the function, it's going to flip it over the y-axis. So let's see this in action. All right. A negative out front flips over x-axis, negative inside flips over y-axis. So how about this one? If we look at f of x equals the square root of x, we should all recognize that function. Let's compare that to putting a negative in front of it. And let's compare that to putting a negative inside of it. According to what I just said there from those notes, we know the first graph looks like this, right? We have to know that. And now let me see, I'm going to get through everyone today. Raquel, have I called in you? No, Raquel?
I'm here.
Okay, how's it going?
Going good.
Good, good. Okay, so Raquel, what is this? What's going to happen here? If I put a negative in front of the square root of x, what's going to happen?
It's going to reflect over the x-axis.
Over the x-axis. Good. So it's going to take it and draw it like this, right?
Mhm.
Okay, and then what about this last one? Because the negative is inside.
It rotates, reflects across the y-axis.
Why? So it would look like this. Do you agree?
Yes.
We're taking the original graph over here and reflecting, or you could even say rotating around the y-axis, and it becomes this. Good. All right, that's it. Those are all the transformations. Now it's about, can you draw me something if I give you a bunch of them mixed up together? So how about, no, let's not do that. Not yet. Okay, how about this one? I want you to sketch this to the best of your ability. Rough sketch, right? I want you to do f of x equals, let me see here. Let's stick with some of these functions that we've been doing today. How about this? -4 square root of x plus 3 minus 5. Okay, take your time. I want you to see if you can draw me this. Well, I say take your time. You want to be kind of fast, but do y'all want all the transformations up here? Do you want me to put them up here? Will this help? I can grab this. Let me just grab this and put it on the page for you in case you need it. Okay, so you're going to draw me a sketch of that. If you finish that, okay, if you finish this one, I want you to try and draw me this one. I'll put it down here. It's almost the same thing, except inside, I'm going to do something different. I'm put -x plus 3. Okay, So this will be number 1, this will be number 2. All right. Let's take some time to do that. And I'll put the poll up again. If you finish the first one, let me know on the poll, okay? The second one's kind of a get you to think a little bit. Remember, I only say yes on the poll if you finish the first one. We're gonna go 1 more minute on the first one. Okay, that's almost everybody there. All right, so let's talk about this first one. Michelle, you're up. How's it going, Michelle? Michelle? No, Michelle? All right. Now, the last person I have on the list here is Henry, but you already responded, but do you want to go for it, Henry? Tell me what you did.
Yeah, I can go for it.
Okay, so on this first one, what did you, just kind of talk me through how you did this?
The first thing I did was I moved it left 3.
Okay, and when you say it, what do you mean it?
Oh, the radical function. So
It looks kind of like that, right?
yeah, like that.
Okay,
Oh, I don't
and you've
know
got
how to
this
describe
point
it.
right there. And you said you're gonna
Right.
move which way first?
I moved that point left 3.
Okay, so the first thing we did, left 3, and that comes from this +3 inside, right? That was the first step.
Right.
Okay. And then keep going. What'd you do next?
And then the next thing I did was move it down 5.
Okay, so here's F3 like that. That was -3. So that's where Henry was after the first step. And then what did you do?
And then I moved it down 5.
Okay, so let me ask you why you did that. Think about order of operations. If I asked you to plug a number in here right now, like let's say I told you to plug in 1. You do 1 plus
it has
3,
to be
right?
X. Right.
Pardon me?
Oh, if I plugged in, what was that? Sorry.
If you plugged in 1, you do 1 plus 3, right? You get 4, right?
Right.
Then you do square root of 4, that would give you 2. And then would
Yeah,
you
I messed up.
subtract 5 or would you multiply the -4 next?
No, multiply the -4.
Okay, so that's what you need to deal with. You need to deal with this before you try and move it down 5.
Okay.
So tell
So
me,
then-
this is kind of 2 things. Tell me what each one of them are doing.
So then the first thing would be vertical stretch by 4.
Okay, so that's the next thing. The second thing is a vertical
And then
stretch by 4. Okay, and then the third thing would be what?
and then you would reflect that over the x-axis.
Reflect the x-axis. Okay, and then Henry, fourth step,
And then you
down 5.
then
Right, down 5.
and I see how that would mess it
You
up.
see how it's a major difference between doing it that way?
Yeah.
Okay,
It'd be below the x-axis.
yeah. So we got the first step was left 3. The second step was a vertical stretch. I'll do that in black. So a vertical stretch, all that really does is this, just stretches it out. That's the second step. Then the reflection over the x-axis, that's our third step, would take that stretched one and do this over the x-axis. Y'all following? Left 3, vertical stretch, reflect over x. And then finally, the whole thing down 5. So I'm going to take that point that's still here. I'm going to move it down 5. 1, 2, 3, 4, 5. There's my new point, and it's still been vertically stretched. There it is. Now, just to show you, just to clarify, if you had done it this way, right? If you first go left 3, 1, 2, 3, right? -3, like that. If you did go down 5, Henry has already seen this when he looks at it again, but if you do the down 5 first, 1, 2, 3, 4, 5, now you're here. Okay,